Today we're going to talk about graphing quadratic functions. This is the standard form of a quadratic. Y equals ax squared plus bx plus c. Knowing that the b or the c can be positive or negative, as well as the a, but the a can never be 0. If it's 0, then of course we have no quadratic. So we talked about finding the axis of symmetry, or knowing that it's the middle or the symmetrical line that runs through the middle of the parabola and through the vertex. There's actually a formula. We know we write it as x is, but the formula is taking the negative b over 2 times whatever a is. Now the negative is part of the formula, so if there happens to be a negative b in the equation, we have to have a negative negative. So let's do an example. So the first is an example here of 2x squared plus 4x plus 3. So this time we have a y-intercept, and we know that this is a positive, so we're going to have something that opens up. It's a 2, so we know it's going to be narrow compared to the parent function, but we haven't talked about what happens with this middle term here. So we've learned early in the year how to factor trinomials or quadratics. So we could factor this and find some points, but we're going to talk about finding the axis of symmetry first. So we're going to take the negative b over 2a and first find the axis of symmetry. So our b value is 4, so we're going to put it into our formula, negative, and we're going to put in the b, the negative is part of the formula, and then 2 times, and what is the a value? That is 2. And we're going to simplify. Negative 4 over 4, which gives us a negative 1. So x is negative 1. We're going to go to our graph paper, and we're going to make a little dotted line. I'm going to use a highlighter to show this. On negative 1, x is negative 1. Our second step, we're going to take, knowing that x is now negative 1, that is our axis of symmetry, our AOS, we're going to then plug it in and find our vertex. So our vertex is always a point, negative 1, we know our x is negative 1, so now we're going to plug it in everywhere that there's an x. So where we see x's, we're going to plug them in. So 2 times negative 1 squared plus 4 times negative 1 plus 3. Negative 1 squared is a 1. A 4 and a negative 1 is a negative 4, and then plus 3. A 2 times 1 is 2. We have negative 4 plus 3, and so then we simplify down, we get 1. So we know our y value is 1. This is all equal to y. So now we know our vertex. We know our turning point, our true point of our vertex. So we go over to negative 1, 1, and here will be our vertex. We know this is going to open up, so it's going to go up in a up smiley face. So this is going to be a minimum. So let's go to step 3. So in step 3, I have my axis of symmetry already and my vertex point, and now I'm going to make a table and get at least 4 more points. Now I can choose whatever points I want. I don't have to go ahead and put the negative 1, 1, because I already know what that's going to be. That's their match. So I just need 4 more points. I have 1 point, so I need 4 more. So I'm going to use negative 2, 1, 0, and 2. And when I plug this in to the equation, I'm going to get the output of 3. Now you can use your calculator to help you with this, quick mental math to do so. When I plug in 1 squared is 1, times 2 is 2, and then 2 plus 4 times 1 is 4, that's 6, plus 3 more gives me 9. When I plug in 0, these cancel out here. 0 squared is 0, times 2 is 0, 4 times 0 is 0, and then I get 3. And then I'll go ahead and plug this one in, I get 19. Okay, then I'll plot those points on my graph. So if you notice, I don't have a big enough graph to plot to 19, not on my paper. I went ahead and plotted the 2, 3, or negative 2, 3. Let me do negative 2, 1, 2, 3. And I have the 0, 3, and I have the 1, 9. So if I need 1 more point to have 5 points on here, because I can't plot this one, I know that this is symmetrical. So notice this point here is 2 away from my line of symmetry. Well, we know parabolas are symmetrical. So if I go on the opposite side, 2 away, there is another point. So now I can connect my parabola, and that is completely graphed. All right, so now Let's review the procedures. First, we find the axis of symmetry using our formula, negative b over 2a. Once we find the axis of symmetry, we plug that in, that value, x is, into our formula, or back into our equation to find the vertex, which is always a coordinate. Then we make a table for at least 4 more points. You need to make sure you graph as you go. So I want you to try this one on your own. Y equals negative 3x squared plus 6x plus 5. Okay, you can see here that our AOS was 1. We then plugged it in and found our vertex of 1, 8. It was axis of symmetry was in highlighted, a little dash. You can use your pencil to do that. It's kind of an invisible line, but it's good to put the dash on there. You know your vertex is going to be there. And then I made a table. What's boxed here is my vertex. You can put it back in your table. You know that's going to be your turning point. So when things start being exactly symmetrical on either side, you can see those points are exactly the same on either side of where they'll go. This one goes down because we had a negative coefficient, so we have a maximum. And then we can look and see that we know it's pretty narrow because that was a 3, bigger than 1, and we are completely finished. All right, let's try another one. This one is going to be a 4-star. You'll notice the difference here is we have an inequality sign. So I don't want you to freak out about that. I want you to take it in stride just like we've been doing the others. See if you can go ahead and plot it. But before you draw your parabola, put your little dots on there, I want you to stop. So see what you can do. Okay, so I found my AOS, which was 3/2. Sometimes 3/2 are very hard, but that's the same as 1.5. So I kind of eyeballed it in the middle and put my axis of symmetry. Then I plugged it in and found my vertex. Just plug it into where x was in my equation. And I found that y is negative 25/4. So I kind of eyeballed there because that's 6 1/4. So I eyeballed down where it is. Then I made a table. I did a few extra points just to kind of give because we noticed that we got a lot of them really close together at the bottom. And once I got all the points on there, I stopped. And because we're talking about inequality, we've got to then ask ourselves some more questions. Should our parabola line be dotted or solid? So remember when we have something that is less than or greater than and equal to, so this bottom line right here, this equal to line, tells us it's got to be solid. So we're going to make it a solid line. If it didn't have that, it would be a dashed line or dotted line on our parabola. Now, because it's inequality, we have lots of different solutions that could make this equation true. So we've got to pick a point and check it. So just like when we did inequalities, we do the same way. The easiest point always to pick, if you can, if it's not on the parabola, you don't ever want to pick a line on the parabola, is 0, 0. So I'm going to pick 0, 0, and I'm going to plug it in. So 0 squared minus 3 times 0 minus 4 should equal, if this is a true, it should be greater than or equal to 0. So let's see if that's true. 0 squared is 0. Negative 3 times 0 is 0. So we get a negative 4 is greater than or equal to 0. Is that true? No. We know that 0 is less than, or greater than, a negative number. So we know it can't be less than. So we can't shade inside the parabola. We would actually shade all of this area out here. And of course, our parabola could keep going forever and ever, and all of this would be our solutions. Now you have a few practice problems. Make sure you show all steps, all pieces, finding your AOS, your vertex, creating a table, and graphing on graph paper. Calculators can only be useful for the small mathematical situation, but you need to show all the work by hand.